Alright, today we're going to be looking at quadratic functions, graphing them, the things that you need to graph them, and then looking at some allocation problems. The graph of any quadratic function is a parabola. And how do you know something's a quadratic? Well, its highest power is squared. The axis of symmetry is x equals h, and that's when we're in vertex form, but we'll look at vertex form and we're going to look at our general form and factor form. And the vertex is located at the point that we call hk. So vertex is either the lowest point or the highest point you can see in those pictures. The vertex and the axis of symmetry is the vertical line that would run through the vertex. So we have three forms that you may see of the quadratic function. One is our general form. And our general form is just the one that is in order, ax squared plus bx plus c. Then we have what's called the standard form. Standard form is also known as vertex. That's the f of x is equal to a times x minus h squared plus k. And this is the form that you can see the vertex. It's also the form that we use when we're doing transformations because you can easily see how it moves horizontally, vertically, and then how it gets affected by a. If it's negative, we know it's a reflection. If it's outside the function and there's a number greater than 1, we know it's going to be a vertical stretch and so on. And the factored form is f of x is equal to a times x minus p times x minus q. So this is when it's already been factored. Sometimes you're given it that way. Now, of course, you could always go from factored to general and then work a problem that way. If the number in front, if our a for any of these out front is greater than 0, we know, or meaning that it's positive, we know that it opens up. And then if it is less than 0 or negative, it opens down. So to graph a quadratic, we like to have our vertex. From our vertex, we can figure out our axis of symmetry, and that just helps us see how it's symmetric. So how do we find the vertex in these forms? Well, three forms, we have three different ways. So the general form, if you're finding the vertex, you take negative b over 2a, and that gives you the h part. And then to find k, find where it has moved vertically, you do the f of that value, that h value. So let's go ahead and try this with this example. So finding our h, and that's this our first point, or our x value of our vertex. We do a negative b, so it's a negative negative 3 over 2 times whatever a is. In this case, a is 2. So that gives us 3/4. So that's where the vertex of that would be. And the x value. Now to find the k, or the y value of the vertex, we would plug it in, plug that 3/4 into our function. So 2 times 3/4 squared minus 3 times 3/4 plus 1. Now with that fraction, you just put it in your calculator, and you end up getting k is equal to 1/8. So for this problem, our vertex, I'm going to erase out my work so I can put it in here. Our vertex is at 3/4 for x, or h is what we call it, and then 1/8 for our y value of that vertex, or the k referring to our vertex. Our axis of symmetry is just x equals that 3/4. That's where you would be able to fold the parabola. Now looking at vertex form, that's the easier one. If it's in vertex form, I can just look at the equation and see what my vertex is. That's the nice thing about vertex or standard form, because it is just this value here. that's telling you your horizontal movement and your vertical movement, how the vertex has been affected. So our vertex for this one is 3, 1. And remember, even though it says a -3, you might want to think that it's negative. Remember, that means it goes to the right. We talked about that when we did transformations. And then our axis of symmetry, which I'm calling AOS, is x equals 3, which is always that x value of our vertex. And then when we look at factored form, we have a different formula. We would add up our factors and divide by 2. So we're going to average those factors, and that would be our x coordinate, or our h of our vertex. And then to find the y coordinate, or the k, we would just plug that into the function. So for this, to find my h, I'm going to do the average of those. So 3 and -3 divided by 2 is -9. By averaging them, plus 0 divided by 2, which is 0. That's a nice point to get, because 0 is kind of easy to plug in. So then I'm going to plug 0 into the function to find my k. That means I'm doing the f of 0, which is 3 times -3, which is -9. There we have our point. So our vertex here, vertex is 0, 9, and then our axis of symmetry would be y-axis. So that's how you find the vertex from all three forms. Easy to do. Yes, you do have to remember some different formulas. Really only remembering those for the general and the factor, because the vertex form you can tell from the equation. If you don't want to remember both, you can always change the factor to the general, just by multiplying and distributing, and then you would just have to remember the one. Now, looking at graphing, how do we graph from these three forms? Well, no matter which form you're doing, you always first decide, you have to think about this. Is this going to be a parabola that's opening up or down? So you look at the number that's in front of your quadratic term, or in front of your function. In this case, we're going to be opening up for that first one, up. Our one that's in standard form is going to open down, and our one that's in factored form is going to open up. So looking at the vertex, for the general form, remember we have to do the negative b over 2a. So to find my h, I'm doing -6 over 2 times 1, which is a -3. And then I have to plug that -3 in to find the y value, or what we call k. So the f of a -3 is going to be -3 squared plus 6 times a -3 plus 5, which, when you do that all out, you get 3. So our vertex ends up being, let me double check that, because I changed the problem. Let's double check. Let's actually do the math, because I changed the problem. I know to see that. So 9 minus 18 plus 5 is going to be a -9 plus 5, which is a negative. It's going to be a negative 1. Change that on my copy, so remember. All right, and then that means that our vertex is at -3, -4. I'm going to write that down, trace that word down. It opens up. The vertex is -3, -4. Then we need to find our y-intercepts. So, because we're going to be able to plot our vertex, -3, 1, 2, 3, down 1, 2, 3, 4, right there. Sorry about that. I've already felt that. Did I have it right on there? Right there. Okay. Then I need to find some more points. Well, one point that's easy to find is my y-intercepts, because to find the y-intercepts, you're just going to plug in a 0 to your function. So you're going to do the f of 0 And then you're going to plug that in. So that's 0 squared plus 6 times 0 plus 5. So that ends up being 5. And plus 0 equals 5. So that gives us an easy point to graph. So we go to our y-axis, because it's our y-intercept, and we go to 5. 1, 2, 3, 4, 5. Then we find our x-intercepts. Well, to find our x-intercepts, we have to solve this. To solve that, we need a factor, because that's the only way you can solve something when we have a variable with an x button and another variable. So we would get x plus 1 and x plus 5. That's what that would factor to. Which means our solutions would be -1, because what would make this 0? -1. And then what would make this 0 is -5. So those are our solutions. -1, -5. Not here. -1. Graph those, -1, -1, and that's enough to make the graph. So not too bad. I mean, it requires a little bit of work there, but nothing too complicated. And then what about if we're in standard form? So looking at our standard form, our vertex form, that's what I prefer to call it. We know this one is opening down. The vertex we can find easily just by looking at it. We know there's going to be a -1 and -2. How do I know that? Well, I look right here. What would I put in to make that a 0? -1. And then this tells me my vertical shift. So -1, -2. Then I need to find my y-intercept. So when I'm plugging in a 0, so I'm doing the f of 0, get -0 plus 1 squared minus 2. So that's going to be -1 squared minus 2 to the -1 minus 2. This is in parentheses. So that's going to be -3. So plug in a -3, 0, -3, that is, right, this one. Now because I know they're symmetric, I know that this point is all, remember that's where I get folded is on that vertex. So that's a point that I don't even have to do when we put plugging into the table. And then finding my x-intercepts, I have to set that equal to 0 and solve. Now, I already know this is going to be no solution. Or it's not, we're not going to be able to solve it, not in the real number system. I know that because I know that my parabola is going down. I can see it's not going to cross the x-axis. But if I wasn't sure if I was just going through the motions and solving it, not really thinking about it as I was graphing, I would set that equal to 0. Then I would add 2 to both sides. Then I have -x plus 1 squared equals 2. Then I have to get rid of that -1. So I would have x plus 1 squared equals a -2. Then I'd have to take the square root of both sides. And right there I'm in trouble. I can't take the square root of a -2. So I don't even need to go any further. I know that this is going to be a complex number, so it's not going to have solutions in the real number system. If I wanted to get another point, you could just go ahead and pick another point on either side. I already have something for -1. I have something when it's a -2. So, and I have something when it's 0. So I could go with 1. I could find the f of 1. If I just wanted to be careful, I really just need those 3 points. It's enough. But f of a -1 would be -1 plus 1 squared minus 2. So that's going to be -2 squared minus 2. That's in parentheses. So it's going to be -4 minus 2 So at -1, or at +1, we have 6. 1, -6. 1, 2, 3, 4, 5. That's not pretty easy. Probably one of the easier ones to do, especially because you have the vertex. All right, and then what about factor form? Well, to find our vertex, remember to find the x-coordinate, we average. Formula is minus, so you've got to be careful here. It is a -2 plus 4 divided by 2, which is 2 divided by 2, which is 1. So that's our x, and then I plug that in to my function, to my k is equal to the f of 1, which is equal to 1 plus 2 times 1 minus 4, 3 times a -3, which is a -9. So my vertex is going to be at 1, -9. We already know it's going up. It's positive. So 1, -9, it's way down here. We're going to use more information. So we need to find our y-intercept, so we have to do the f of 0. It's going to be 0 plus 2, which is just 2, times 0 minus 4. So what's that going to be? 2 times a -4, which is a -8. So at 0, it's a -8. That means it's going to be -8 over here, because remember it's symmetric, so we can just go up both sides. And finding my x-intercepts, nothing easier to find than your x-intercepts when you're in factor form, because remember you're just solving that. So x would be a -2, that's one of them. And the other one is this. So x is -2 and 4. -2. There we go. Now, that's method 1, which is finding the vertex, finding your y-intercepts, finding your x-intercepts, graphing. If you don't have x-intercepts and you need to generate some more points, best thing to do is to just plug in some points on either side of that vertex. Now, what about using transformations? We did this when we did our transformations last unit. So you can use transformations, but it only works when you're in standard or vertex form. So if I'm looking here, my horizontal shift is a negative, it says -3, but remember that means it goes the opposite way, so it goes right 3. So remember that this is my parent, because we're doing quadratics today, so I'm going to the right 3, so I already know I'm moving over this way. Stretching or compressing, do I have anything out front? No. If I did, I'd have to take that into account, think of how it would look, but I don't have one. Do I have a negative out front? No, so I don't have a reflection. And then my vertical shift is down 1, and I need to go down 1. And then it's just the parent, which, if you recall, the parent is symmetric. And you could plug those points in if you wanted to. If you wanted to do the f of 2, just to see where it is, that would be a -1 squared minus 1, which is 0. Then you could do the f of 4, because that's on the other side of the vertex. Our vertex was +3, -1. On the other side of it is 4. If we plug that in, you would get 1 squared minus 1, which is 0. You could do a few more points if you wanted to. You could also easily do the y-intercepts, because the y-intercept is always easy to do. If you wanted another point, plug in a 0 for x, 0 minus 3 squared minus 1, which would be 9 minus 1, which is 8. So 1, 2, 3, 4, 5, 6, 7, 8. So my graph's a little bit off. There you go. What about if we like vertex form, but we have something that is in standard form? How can we convert it, or it's in general form, we want to convert it to vertex form. So what do we do to do that? Well, to be able to do that, we have to complete the square, which you should remember from algebra 2. So first we start with our original function. F of x is equal to x squared minus 6x plus 4. This is not a perfect square trinomial. That's why we're having an issue right there. We can't factor that and have it be just a binomial squared, so we need to make it that way. So what do? First we're going to group our variable terms. So what's that mean? That means these two are together. Looking at those. Those two together, I need to add something to it so that I can actually factor it. I need to complete the square by finding b divided by 2 squared. So b divided by 2, so that's a negative 6 divided by 2, and then that needs to be squared. So that's going to be negative 3 squared, which is 9. And notice what it says, I need to add it and subtract it, because remember, I can't add something to an equation and it still stay that same equation. So if I'm adding it and subtracting it at the same time, I'm actually adding nothing to it. So this becomes f of x is equal to x squared minus 6x plus 9 minus 9 plus 4. Now I'm grouping, because this was the whole purpose here, I'm grouping that perfect square trinomial. And this is just my leftovers, and that's going to actually give me my vertical movement. So I'm going to group the perfect square trinomial. Now I can factor that. I can factor what's in that group. That's just x minus 3 quantity squared. It's a perfect square trinomial. And then on the outside I have minus 5. It's minus 9 plus 4 over 5. And now it is in vertex or standard. And I can see what the vertex is. Positive 3, negative 5, I can graph it from that. What if you're given just the vertex and a point? Can you come up with the equation? Oh, you can. Now, being that you're given the vertex, you want to start by coming up with your standard form or your vertex form, and then if you want to go to general form, then you can. So remember that the standard form is f of x is equal to a times x minus h squared plus k. So we're going to plug our vertex in. Remember that this is our h, this is our f of x is equal to a. We don't know a. Figure that out in a minute. X minus 3 squared plus 4. Now, we need to find a so we can have the actual equation. We can't have an equation with an a in it. But we know an x and a y. This is an x. This is an f of x. We can use that information and plug it in. This goes back to your algebra when you're finding an equation given 2 points. That's what we were given, 2 points. So f of x is 3. 3 is equal to a times 2 minus 3 squared plus 4. And we can solve this for a. Is equal to a times negative 1 squared plus 4. 3 is equal to a times 1 plus 1. We want to solve for a. Minus 4. Negative 1 is equal to a times 1. Do we have to divide by 1? Not really, but it makes you feel better. So there we go. Now we have our a. So our equation in standard form is the f of x is equal to a negative 1. We don't necessarily need to put the 1. X minus 3 squared plus 4. And there's our equation in our vertex or standard form. Now, what if you need to put it in general form for some reason? Could be test question. So what am I going to do? Well, I'm going to just go ahead and multiply it out. This is x minus 3 plus 4. This we multiply together, which is -1 times whatever this is going to be, x squared minus 6x plus 9 plus 4. Goes back to that one that we completed the square one. We're going to distribute that negative x squared plus 6x minus 9 plus 4. And then do that math right there. So -x squared plus 6x minus 5. And that is the general form. Now application. Because the vertex of a parabola represents either the min or the max of a quadratic function, in application problems that often suffices to just find the vertex. So here we have a function that's finding the minimum cost. So we know we're looking for the vertex, the lowest one. So a company that produces motorcycles has a per unit production cost of that function, where C is the cost in dollars to manufacture a motorcycle, and then X is the number of motorcycles produced. How many motorcycles should be produced in order to minimize the cost of each motorcycle? What is the corresponding minimum cost? So we're needing to find the vertex, keeping in mind that X is the number of motorcycles produced, and C is the cost. So even though we're going to find the vertex, we're finding H and K. It's K that answers the question, because that's our output. So looking at this, it's in our general form. So to find the vertex, we do -b over 2a. That'll give us the H, or in this case, our X. And then to find the C, or our output, we have to input that back in. So doing this, find our H, which in this case is the same as our X. We are going to do a -b, so a -15 over 2a, 2 times 0.05. So then if you put that in your calculator, you end up getting 150 motorcycles being produced, and then what would that cost be? So we're going to plug that into our function C. C of 150 is equal to 2,000 minus 15 times 150 plus 0.05 times 150 squared. And when you do that, you get $875. So that right there. Another problem. Finding the dimensions of a max. You have just bought a puppy and want to fence in an area in the backyard for her. You buy 100 linear feet of fencing from Home Depot and have decided to make a rectangular fenced-in area using the back of your house as one side. Determine the dimensions of the rectangular pen that will maximize the area which your puppy may own. What is the maximum area? So we know that we have one side, we're going to call that X. And then this, we have 100 feet of fence, so this is going to be 100 minus whatever we use on the sides. We're making a rectangular, so minus 2. So to find the area, that's length times width. So we're going to do X times 100 minus 2X. So area is equal to 100 X minus 2X. Right, there we go, it's a quadratic. So we know that we're looking for the max. The max. A is our output. That's our area. So we are going to look for this vertex. So to find the vertex, same thing we did up front. To find up top, -b over 2a, and to find the k value, we plug that into our function. So -b, so that is -100 divided by 2 times a, which is a -2. So that is 100 divided by 4, which is 25. So that's our X, or will be our H on the picture. And then to find our Y or our K, we would plug that in. So we would do the, let's say, the A of, because we're using A, the A of 25. That's 100 times 25 minus 2 times 25 squared. And when we do that, we get 1,200. So that would be our area.